Okay, so let's use Desmos to do some graphing of quadratic functions. I highly recommend that you also open up your Desmos app and follow along with what I'm doing, just so you familiarize yourself with all the different ways of doing things here. I have y equals x squared. That's what I'm going to start with. This is sort of the, this is kind of like the most general quadratic function you're going to see. It's the easiest one to graph. The points are super easy to calculate. So you will, usually what we do is we tend to reference this graph in comparison to whatever graph we're looking at, oftentimes when we're talking about quadratics. But in any case, I've got y equals x squared. There's a nice little feature in here. If you take a look at the little wheel up at the top here, I'm just going to click on that. And next to the y equals x squared, you'll see like a table of values, and also you'll see like the double pages, which is a copy function. So I'm just going to copy this function, and what I'm going to do is in the second one, I'm just going to click on the table of values option. And there you go, I have a table of values generated. And what's really nice is that you can actually add to the table of values. So I'm going to do that. I'm just going to keep adding. I'm going to say, okay, that's 3 and that's 4. And it'll just generate the values for you. And then if you notice the points, the points that you have on your table of values, those coordinates are actually highlighted on your graph. So you can see that, you have 0, 0, and then 1, 1, and 2, 4, 3, 9, all that good stuff. Okay, the other thing that you can do in Desmos, which is pretty sweet, is you can add, I'm going to add a coefficient, A. And as soon as I do that, Desmos recognizes that A is not a variable because X and Y are my variables, right? X and Y are changing. A is not a variable. A is my coefficient. And so if I click on this where it says add slider, it will allow me to change the value of A so that I can see how my graph is changing. So if I just, I myself can slide this, right? Like this. Okay. But also I can hit play as well. Okay. So what I'm going to do is, I'm going to get rid of the table of values, because what it's actually doing is, the reason why I have two graphs is that my table of values is specifically referring to the graph where A is equal to 1. So if you notice, they'll just overlap when I do one, right? But my y equals ax squared, that graph is the moving graph. You can see that, right? So what I'm going to do is I'm actually going to get rid of this, and I'm going to generate a new table of values. So again, I'm going to copy this, and then I'm going to say, okay, so now my table of values and my graph and, everything matches. And again, I can go here and I can say this is, 3 and 4 and 5. And again, we can see those points along here. Okay. And then let's take a look at what happens when A is changing. So I'm just going to hit play, and I'm just going to watch it go. So if you notice, when A is positive, your graph is opening upwards. And when A is negative, your graph opens downwards. And something we need to recognize is when that flip happens, okay, which is right about here, okay, when that flip happens where the graph looks like it's flipping over, like it's, coming from the negative y values into the positive y values, you'll notice that A equals 0. There it is. It's a straight line. It's a line actually at y equals 0. That's the equation of that line, y equals 0. This is not a quadratic function, obviously, because it's a straight line. It's a linear function. So this tells me, I can state a couple I can say a few things about A here, okay? One of the things that I can say about A, so I'm just going to take a screenshot so you can see exactly what I'm doing, so I can write on the screen. Where is it? There we go. Okay, so when A is greater than 0, you'll notice that the graph opens upwards. Okay, when a is less than 0, the graph opens downwards. And when a is equal to 0, I get this straight line on y equals 0, which makes it linear, not quadratic. So when I'm talking about quadratic functions, when I'm talking about this general form of a quadratic function, I can state some conditions on a, right? A cannot equal 0, because if it does, it's actually not quadratic anymore. And I know this, I know that when a is greater than 0, it's opening upwards, and when a is less than 0, it's opening downwards. So I'm able to say this about a. So when you notice that coefficient on x squared, so if I see something that looks like this, like that, for example, I know that because the coefficient on x squared is negative, this graph, whatever it may look like, I know that it definitely opens downwards. And I know this because a is negative. Okay? If I have a equation that looks like this, something like that, I know that this graph definitely opens upwards because a is positive. Okay, so I can confidently say that about my graph. And that is a property that all quadratics have based on what a is. Okay, so that's something that's worth noting. The other thing that we want to draw attention to in our graph is the table of values. Okay, so I just want you to, so I'm going to set a equal to 1. Okay, and if I take a look at this graph, if we start looking at these points and sort of how they're changing, I'm just going to click on them so we can see them super obvious. I'm going to take another screenshot so I can write on it. Okay, when I see the changes taking place from one coordinate to the next, you'll notice that x is just increasing by 1. Okay, so that change is constant. 1, 1, 1, 1. And on the y, that change is not constant. But you'll notice something. From 1 to 4, well, actually, let's start at 0. Let's start at the vertex, right? The vertex is the lowest point on your graph. Okay, so that's your vertex. And when I start from the vertex and I go in either direction, you'll notice that I'm increasing by 1, increasing by 3, then I increase by 5, 7, and 9. And if you notice the change, the second level change, so I have 1, 3, 5, 7, and 9. The second level change is all 2s. This is what tells me that I have a quadratic function. Now, this number doesn't have to be 2. It could be 3 or 8 or 6.9. It doesn't matter. It just all has to be the same. Okay, it has to be the same. But if it's not the same, then that means I don't have a quadratic function. So let me show you another example so it's super obvious. So let's say a is not equal to 1. Let's say it's equal to, let's say it's equal to 5. Okay. Now when I look at the change, if you notice, I have plus 5, plus 15, plus 25, plus 35, right? As I go from one point to the next. Now my change is 5, 15, 25, but my change with like my second level change is now 10. It's 10 everywhere. Okay, this again, this is what tells me I have a quadratic function. And you can see it, you can also see it in, like on the graph, you can see it, okay? So here is my change. It's my first change, it's my positive 5, okay? And then my next change from here to here is going to be positive 15, okay? And it's just gonna keep going that way. Okay, so those are the, that's the influence that A has on your quadratic function. In the next video, I'm going to talk about the influence that B and C have on your graph. So if you're in the general form, ax squared plus bx plus c, now we've talked about A. Okay, we know what's going on with A. We are going to look at B and C and how that influences your quadratic function. Okay,